Hello everyone, my name is Hilmi Kilickaya and the name of my project is Music in Memory Lane, a song recommendation system. When I was a kid, one of the things I enjoyed was playing with the CD player and making a list of my favorite songs. It was awesome at the time. In the 90s, most of us couldn't imagine that we would be accessing hundreds of thousands of songs with one click, let alone that the app could recommend different songs based on our preferences and playlists using machine learning. One of the most used machine learning algorithms is recommendation systems. I just want to go back and play with my favorite childhood game in a different way, not only listening and creating my playlist, but creating my own recommender system to find my favorite songs. In my project, I created a recommender system with different features to compare them. I will explain all of them as I go. My dataset contains over 18,000 songs from 6,000 different artists. There are 6 genres and 24 subgenres. I also have Spotify audio features in my dataset, which include danceability, which tells how suitable a track is for dancing based on a combination of musical elements. Acousticness tells whether a track is acoustic or not, and instrumentalness predicts whether a track contains vocals. I started my process of cleaning lyrics, then creating a bag of words. Tf-idf vectorizer evaluates how relevant a word is to a document in collection of documents. Tf-idf focuses on the importance of words and not just words that appear often. Focus on unique words. Words are given weight of how they relate to one another. The figure on the right shows how many words each document contains. I chose topic modeling for the lyrics to find out what these songs were about. LDA stands for latent Dirichlet allocation, and it's a type of topic modeling algorithm. The purpose of LDA is to learn the representation of a fixed number of topics, and given this number of topics, learn the topic distribution that each document in a collection of documents has. On the right, you can see some of the topics in my documents. Topic 1 looks like a Christmas songs. Topic 2 looks love songs. Topic 3 is maybe rock songs. To find the similarity between the songs, I used cosine similarity, which finds the smallest distance between vectorized features. For instance, these 2 songs from my dataset with given 2 features, their cosine similarity is 0.99. There are my 2 favorite songs, which most of you might be familiar with, Just Dance by Lady Gaga and The Scientist by Coldplay. There are some features of these songs, and I'm going to use these songs to show recommendations. In my first recommender system, I used Tf-idf vectorizer, which looking for the similarities between the words. Even the recommended songs belong to the different genres and are musically different. There are 11 common words between these lyrics. User might not necessarily like the recommendation, but there were some songs actually I enjoyed a lot. My second recommender system with LDA. The results are much different than the previous recommender system. The songs are more related to each other meaningfully and also mostly belong to the same genres. But as a listener, it wasn't the best recommendation for me. Spotify has audio feature, as I explained at the beginning. To find this cosine similarity in my third recommendation, I use these features. I can say so far it is the best result I got. The songs belong to the same genres. And last but not least, I have a recommendation system that checks similarities using audio features and topic modeling. Even though results are very subjective, I can tell I got the best results with my last model. There are some similar songs between the last 2 recommendations. The reason I have a small data set, With a bigger data set, I would get different results. These are the tags I used in my project. And in the future, I am planning to collect more data using Spotify API and use cloud computing to improve my model and create an interactive app for users who can get their best recommendations by entering their process. Thank you.